Hello everybody, I'm Samar. I welcome you to this tutorial on matrix multiplication HLSIP using the 2024.2 version of Vitis and Vivado. So let us start. The first step is to set the workspace for our project. So when we open Vitis Unified IDE, we can click on Set Workspace and we can make a new folder. I've already made a folder, so I'll just select that. Now, depending on what you clicked during the installation process, the screen may look a little different. If you selected Vivado and Vitis HLS, which is the workflow we'll be using here, this is how it should look like. So now let us start by creating an HLS component. So we can call it matrix unoptimized. In this tutorial, we'll be creating an optimized version of the same code to compare the latency and resources. We can either specify the source files now or we can do them later. We'll do them later. Now we'll be using a ZCU 111 board. So this is the part name corresponding to that board. Click on finish. And now this is my workspace. So I'll create a few source files. Click on new source file. I'll create my header file and I'll create my main CPP file. I'll also create a test bench. Now I have already written the code to save time. So I'll just copy and paste the code. So the code has been pasted. Let's go through the code now. In the header file, I've included all the libraries I need for my project. We'll be using AXI stream here. I've also created a matrix size variable that later, if I want to change the dimensions of my matrix, I can do that very easily. And I'll be using float data type for my matrix. Now we have created an AXI stream. So every element in my AXI stream is called AXIS float T, and this is how we create them. So first of all, we'll set what kind of elements I'll push through in my AXI stream. It's float in this case. And then we'll set the user bits, ID bits, and destination bits. They can be set by default to be 0. Then I'll create a first in first out stream of these data types and I'll call them AXIS data. Now, then I have also initialized my top function. Now in my C++ file, we can actually write that hardware function. We have set AP control to be none so that we don't have to give start signals. And then we have now by default in Vitis 2024, all the optimizations are automatically switched on. So for the purpose of this tutorial, I want to compare the unoptimized and the optimized versions. So so we'll have to explicitly set all these pragmas as off so that Vitis does not automatically optimize our code. So we'll set pipeline inline to be off. We'll also not unroll or flatten our loops. Flattening the loops essentially means if you have 3 nested loops, it will treat it as one loop and unroll everything inside it. So we don't want that to happen in the unoptimized version. Uh, then we'll use the standard matrix multiplication code 3 for loops. And for the output, while getting the output back, we also have to set the tkeep signal as -1 since we're using AXI2. Now we can start writing the test bench. So for test bench, we'll be generating random matrices. I was given a seed value as 1. So we'll be using 10 iterations and every element in a matrix is between 1 and 2 because this number is between 0 and 1. I'll set up my stream just like the header file. I'll create a local stream where I'll take the input. Similarly, create a last signal just like we did in the C++ file. I'll call my hardware function and get the output. I have set the threshold to compare the input output to be 0.0002. If any difference more than this particular value is observed, the code will generate an error. If you want a lesser strict value, we can set this number to be more. And if an error is generated, it will return 1 and RC simulation will fail. We'll also be calculating the root mean square error. So once we have done all this, we can go ahead and set our top function. So we'll create the config, we'll open the config file inside settings. And in the config file, the first thing we have to do is we have to set the top function. So if this blank is empty, we'll write the name of our top function here. So it is matrix my underscore 8 underscore unoptimized. It is important that we name our top functions very carefully, because when we export it to Vivado, by default, the name of our IP will be the name of our top function. If we have created ambiguous names, it will create issues while finding the particular IP. Let us see if we need to change anything in the settings. Now we can set this array partitioning threshold as a very big value, so that it automatically does not partition our arrays. And we'll also disable the array partitioning. Great. So we can now go ahead and simulate our code. Let's run C simulation. So the workflow will be something like this. We'll first create our HLS IP using Vitis. Then we'll export our IP to Vivado. Once we have done that, we will create the bit stream from Vivado. Then we'll create a driver on pig. Great. So the C simulation has successfully finished. We can see that the RMS error is very low. That's good. Now we can run the C synthesis. So let's wait for the synthesis to complete. So now synthesis is completed. The next step is to do the CRTL co-simulation. So we can start with that. And while that is running, let us also analyze the synthesis report. So this is how the report looks like. As you can see, when I click on my loop one, this is my matrix multiplication loop. I can very clearly see the loop is not flattened, since I can see all the nested loops separately. Also, my total latency is 2421 clock cycles. And if I look at my percentage of resources, it is negligible, approximately zero. So it is expected because the board is very big and we have not done any pipelining. So that is great. Uh, Also, we can clearly observe that the maximum latency is for our matrix multiplication, 2128. Hence, this is the bottleneck of our operation. So we'll have to somehow optimize this code. Uh, Now the trip count is the number of iterations my loop takes. So since my matrix size is 8, it makes sense that my trip count is also 8. If I have not done any pipelining, my total latency should be my trip count into my iteration latency. So which is what we are getting here also. 8 into 266 is 2128. Now when they are nested loops, it generally takes one clock cycle to enter the loop and one to exit the loop. So in my from my third loop, as you can see, it takes 30 clock cycles. So it roughly takes 2 to 3 more cycles to come out of the loop and into the other loop. So I got 33 here. And similarly, 264. So one to leave, one to enter, I'll get 266. So it takes 2 to 3 loops, 2 to 3 clock cycles, my bad, to exit from the lower loop and enter the upper loop. So it's very obvious that it is wasting clock cycles. So we can flatten our loop, make these nested loops into one loop, and that will save a lot of latency. So as we can see that the CRTL co-simulation has completed successfully. That's great. Now the next step is to export our IP to Vivado. We'll click on package. This makes the Vivado IP from our HLS code. Now we can see that T data is 32 bits, which makes sense since we're using float, and float is 32 bits by default. And we also have a T keep, T last, T ready signal as expected. We also created a strobe signal. If we look at Pragma, we have there is a separate Pragma section. If we can see that we have disabled all these particular Pragmas, and the only Pragma we have set is our AP control port as none and our AX system. So the package is now completed. Now we can go to Vivado and import our IP there. So thank you. Let's go to Vivado.